This is going to be the fastest video yet, and it is about lesson 94, which is the intro to statistics. This is mostly terminology. You should have all this down in your notes. I'll just read you through what the answers are in case you missed any of this in class. I'll do the first example that'll relate to the homework. So a survey is handing out questionnaires to people and collecting their responses. There are problems. Voluntary response, which is that only some people answer. If you don't feel strongly about it, you may not answer the survey at all. Other problems, people lie, so they might not be truthful to you on the survey that they hand back. And the wording of the survey can influence people. So you can phrase a question in a way that it makes people want to say no or say yes, or to change the number of their answer or whatever. An observational study is observing behavior or patterns without interfering with the subjects of the study. So like standing at the mall and counting how many people go into a certain store. That would be an observational study. An experiment is a scenario designed to test the effect of a stimulus on a specific group. So experiments happen in ways that are created, designed, so that we can isolate specific parts of the effect or result. Now, qualitative data, this is one category, one way that you can break up data. It's qualitative or it's quantitative. So qualitative is non-numerical, for example, like favorite color or name. Quantitative has an N in it for number, so it's numerical. And an example of that would be like height or age. There's another way to break up data. It's a little bit more nuanced, so it's a little better. And that is this right here, which is nominal, ordinal, interval, and ratio. And it goes in that order from weak to strong. So the weakest data is nominal. That's name data, which is qualitative. Ordinal can be ordered from least to greatest. So for instance, the alphabet, or numbers, or you can think about places in a running race, right? Second, third, fourth place. Those can be ordered. Interval is the differences between numerical values have meaning. I don't know where those two letters went. They have meaning. For example, like temperature. So if I say that it is 15 degrees warmer today than it was yesterday, that's a difference. 15 degrees is the difference between those two. And that's actually found by subtraction, which is a difference in the mathematical sense. Ratio means that multiplication and division or ratios make sense. Ratio data is measured on a scale that starts at 0. It has a meaningful 0. So for instance, length, right? And by ratios, I don't mean anything very mathematical about that. I mean like the height of building A is twice. That's a real-world example of using a ratio. Twice the height of building B. Now that makes sense because the height of something would be measured on a scale that starts at 0. There are no negative heights. Now these are the parts of a study. Sample, population, and variables. The sample is the small group that's actually studied. The population is the larger group that is represented by the sample. So, for instance, I might want to say something about high school students. So I can't study all of them, though, because it's too large of a group. I can't ask every high school student in the whole world or even in the whole country. So what I would do is I would pick, let's say, 200 randomly selected high school students. That would be the sample. The variable is the responses or measurements. For example, like height or soda preference, race, gender. Those are the category that all the answers fall under. So those would be the variables. Now, a control group is super important to a study. A control group is a group that a stimulus is not applied to, and it's important for comparison with the treatment group. So if I wanted to test if a new blood pressure drug was working, I would test the blood pressure drug on one group, and I would give the other group a fake drug. Okay, and then I would at the end compare the differences in their improved or disimproved blood pressure. So the group that gets the not real drug, that's the control group. And it's important that it must be the same makeup as the treatment group. For instance, same age, gender, race, socioeconomic background, whatever feels relevant to the study. But the groups need to be about the same. Now, the placebo effect is the reason that we need a control group more than anything. The placebo effect is when you see results from thinking you're being treated. So I'll give you an example of this before I move on, right? So in my blood pressure study that I was just talking about, I have group A and I have group B. Now, group A gets the drug. Group B gets a sugar pill. Now, it's only a couple grams of sugar, so it's not enough to change anything, but the idea is that it's an inert pill. It does not have any drug in it. There's no medication. But they think they're getting medication. And now what happens? If they're both trying to take these pills and they think that their blood pressure is improving, they're subconsciously or even consciously making decisions that'll improve their blood pressure. For instance, both groups might eat healthier. They do, and so do they. They might exercise more because they're thinking about their blood pressure more often. They end up making healthier choices. In the end, Group B might see a 10% improvement. And in the end, Group A might see a 22% improvement. So what we're really interested in is not whether or not the drug works, it's whether it works better than a placebo. This sugar pill up here, that is what we call a placebo. So placebos are actually effective to a certain extent just because the person taking the sugar pill, the nonsense pill with no ingredients, they think that they're being given something that works. So they end up changing their behavior and they see results even though the medication was not real. So that's why in order to isolate the effect of the actual drug, we need to have a control group. So we could say, for instance, that the difference, 22 minus 10, we see a 12% difference above what a placebo would provide. So that does imply that it does work. These could very well be about the same. This could be about 10 or 11%, and then we could say that the drug does not work. Whereas if I hadn't given these people here, and we only get part of the picture, you see, gets drug, 10% improvement. And you would never get that the drug wasn't the thing that was doing it. Now here's the way that we're going to fill out the 2 questions for homework. I don't want all of this. Okay. For this exercise, we're just labeling the parts of the following studies. So television station QUE wants to know the proportion of TV owners in Virginia who watch the station's news program at least once per week. New program. The station asks a group of 1,000 TV owners in Virginia if they watch the program at least once a week. So we want to identify the individuals, the variable. We want to know if it comprises a sample. What's the population? Is the variable qualitative or quantitative? And then identify a quantitative variable, meaning number, that might be of interest. So the individuals in the study, this is what we're talking about. We're talking about the people that are being studied. So who's being studied is what question A is asking. So the answer is 1,000 TV owners in Virginia. The variable is television show viewership. So whether or not they watch the TV show. Right, so you could say whether or not they watch the TV show once per week, but I'm going to say program viewership. We're just asking them yes or no. Do you watch or do you not watch? That's their viewership. Do the data comprise a sample? Yes, I'm not surveying everybody, so yes, it's a sample. What is the population then? We are trying to say something about television station QUE's proportion of TV owners in Virginia. That's the population we're interested in. We could only survey 1,000 of them, but that's the group that we want to talk about, that we want to say something about. Is the variable qualitative or quantitative? So if I ask people, do you watch the program at least once a week? What are they going to say, yes or no? So is that qualitative or quantitative? Is that a number? It is qualitative, because their answers are just going to be yes or no. Those are not numbers. Now identify a quantitative, meaning a number variable that might be of interest. So if I was doing a study about this program, just think about something that the station might be interested in knowing about the TV owners that they survey. So these 1,000 TV owners. They might want to know, for instance, I'm just zooming in so I don't have to switch pages. So they might want to know how many times per week. They might want to know how many TVs do you own. They might even want to know how many watchers are in your family, how many viewers in the household. So any of those are fine because they will get you numerical answers. Okay, so take that example and go on to the back of the sheet. Your homework was 2 and 3, these exercises right here.